Hey kids, this is Mrs. Lowe. We're trying out a little blended learning video on chapter 2.4, writing linear equations. So you should be completing your note guide as I go through it with you here. You should work on the team challenge. We can go over that next class if you have questions, but definitely try that. For chapter 2.4, your learning objectives are to be able to write a linear function in slope-intercept form and point-slope form, and to transform from one form to another, and also be able to write equations in parallel and perpendicular lines. So a linear function can be written in slope-intercept form, which we all know is y equals mx plus b, where m is the slope and b is the y-intercept. If a function is linear, it has a constant rate of change. Slope is the gradient, steepness, all of those are good words, of the line. There are two formulas for slope, y2 minus y1 over x2 minus x1, or you can flip-flop the point, because it doesn't matter which point you consider, the first point or the second. This is also considered the change in the y over the change in the x, or the amount you go up or down over the amount you go right or left. A linear function can also be written in point-slope form, which is y minus y1 equals m times x minus x1, where m is the slope, and x1, y1 is actually a point on the line. Now we're going to be working with this form a lot. Make sure you understand that this can be rearranged to y equals m times x minus x1 plus y1, where the point is x1, y1. Just make sure you understand those are equivalent. There are two special types of lines. Vertical. Vertical is not a function. It's the only type of linear equation that is not a function. And all vertical lines are in the form x equals any number a. So for example, if I had x equals 3, it's a vertical line that runs through the x-intercept at 3. Every point on that line, x is 3. It has a slope that is undefined, U-N-D, undefined, versus a horizontal line. Horizontal line is a function. It is in the form y equals any number, and you can use any letter you want to represent the constant. For example, y equals -1 is a horizontal line that runs through y equals -1. Every point on that line, y is -1. It has a slope valued at 0, up nothing over any amount you want. On to the next page. Here you're supposed to write the equation of the graph line in slope-intercept form and then verify the slope using the formula. Well, I can see there are two highlighted points here, one of which is the y-intercept. So I know that the y-intercept, is 3. I also know that the slope is negative because it goes down and to the right, and I can simply count the rise over the run. So I go up 1, 2, 3, and I go over 1, 2, 3, 4, 5. -3 over 5 is the slope. And I write it in my form, y equals mx plus b. To verify the slope, I'm going to use the 2 points that are highlighted because I know they're integer points. We've got 5, 0, which is right here, and 0, 3, which is right here. I'm going to use this slope formula, y2 minus y1. It doesn't matter which point I use as my x1, y1. I'm just going to do 0 minus 3 over 5 minus 0. I get -3 over 5, which is indeed the slope I found by counting rise over run. In the next part, we're going to write the equation of the line in point-slope form and then slope-intercept form. I'm going to do A with you, and then I'm going to ask you to do B and C on your own, and I will post the answers in the beginning of the second video and continue on. First, we're going to find the slope. Because I know it is linear, it has a constant rate of change. It doesn't matter which 2 points I use. I am going to list the points that I'm going to use. Doesn't matter. 16.9 and 8.5. You will always get the same slope if you do the math correctly, no matter which points you use. y2, 9, minus y1. Or you could call that y1, y2. As long as I'm consistent. I started with the 9, so I start with the 16, minus 8. So I am getting a slope of 4 over 8, which we need to reduce to 1/2. So I know the slope. I don't know the y-intercept, but I know lots of points. So I am going to write the equation in point-slope form. There are lots of point-slope forms because I can use any point I want. Point-slope form is y minus y1 equals m times x minus x1. Just pick a point that you want to use. I will again use 16.9. So I get y minus y1, which is 9, equals m, which is 1/2, x minus 16. If I used another form, or excuse me, another point, I would get a similar equation with just a different point. But when you rearrange it to slope-intercept form, it's all going to be the same. So now I'm going to solve for y and get it in slope-intercept form. I do that by distributing first. So I get y minus 9 is 1/2 x minus 8. 1/2 of 16 is 8. And then the negative 9 will become a positive 9. So y equals 1/2 x plus 1. There it is in step 3 is slope-intercept form. So I would like you to complete the next 2 problems on the next page. And then I will post those solutions so that you can see them, but I want you to try it yourself on the next video.